Welcome back to Mr. Burton's class. Today, we'll be covering the I do for two-step equations. Let's get started. This question says, JP was asked to place a check mark next to any equation in which x equals 7 is a true statement. Check over his work and correct any mistakes. What they're telling us to do in this problem is to check over his work and correct any mistakes. That's the statement that they want us to do. All right, so now we need to look at what our equation needs to equal up to. So it says, put a check mark next to any equation in which x equals 7 is a true statement. So we're going to have a check mark next to each one that x equals 7 is true. So let's get started with looking at the first example, which is question number 1. Question number 1 is 8x minus 15 is equal to 41. Now, with 8x minus 15, we need to go through the two-step process in solving this. So we start by isolating the variable and the coefficient, which is 8x. We want to isolate the 8x by removing this negative 15 from that side. How can we do that? Well, just like in one-step equations, we are going to do the inverse operation or the opposite operation to what's happening there. Right there, it is minus 15. So to zero this out, we need to add 15 so that 15 minus 15 will equal 0. But whatever we do to that side of the equal sign, we must do to this side. So since we added 15 to this side, we also need to add 15 to this side. 1 plus 5 equals 6. 4 plus 1 equals 5. We're going to bring down the equal sign, and we're going to bring the 8x down from this side since that's all that's left over there. Now, we have 8x equals 56. So now what we need to do is we're still trying to isolate 1x to see how much 1x is. So let's go ahead and continue by trying to take the 8 away from the x. So what we see here is we see 8x, and what this actually is, this is actually 8 and it's multiplying times x. So x 8 times. But we only need to know what 1x is. So the way that we can do this is we could do the inverse operation to what's happening right here with 8 times x. It's similar to when we did the inverse operation by adding 15 to both sides. We're going to do the inverse operation to multiplication, which will be division. So we have 8 times x, and we are going to divide by the coefficient that is with x. That's the number that x is multiplying times. So we're going to take this 8x and we're going to divide it by the number 8 because that is the coefficient. The reason why we're doing that is if you have 8 and put it over 8, what does that equal? That equals to 1. Therefore, we know our new coefficient will be 1 in front of the x, which we don't even need to represent. So we could just bring the x down like that. It's inherent that the 1x is x. We bring the equal sign down, and whatever we do to this side of the equal sign, we must do to this side as well. So we're going to divide 56 by 8. 8 goes into 56 7 times. 7 times 8 will be 56. We don't have a remainder. Therefore, we know this one is correct. X equals 7. How can we check that? Let's put the 7 back into the original equation. So what we have here is 8 times 7 minus 15 will equal to 41. Well, we know that 8 times 7 is going to equal to 56. So if we subtract 15, then it should equal to 41. Let's do that now. 56 minus 15, 6 minus 5 equals 1, and 5 minus 1 equals 4. Therefore, we are left with 41. That matches with this number right there. Therefore, that check mark is verified. Good job. All right, let's check question number 2 now. Question number 2's equation is 1.5x plus 4 is equal to 14.5. So we're going to handle this in the exact same way. We're going to be isolating to find out what 1x is. So we're going to do the inverse operation to this plus 4, which will be minus 4, because 4 minus 4 will equal to 0. But whatever we do to this side of the equal sign, we must do to this side. So we're going to subtract 4 from this side as well. These 4's cancel out. We bring the 1.5x down. We bring the equal sign down as we showed here. And then we have 14.5 minus 4. Bring the 5 down because 5 minus 0 is 5. 4 minus 4 equals 0. And 1 minus nothing is 1. Therefore, what we have here is 1.5x is equal to 10.5. So now for our next step, we need to go ahead and we need to divide by 1.5. Why? Because if we divide this side by 1.5, now we have 1.5 over 1.5. And just like our last example, we know that any number that's over the same number is going to be 1. So we've established 1x by dividing. We're going to bring that down. We're going to bring the equal sign down. But remember, whatever you do to this side of the equal sign, you have to do to this side. So we have the 10.5, and we're going to divide that also by 1.5. Let's do that now. 10.5 divided by 1.5. Now, from our previous lessons, we know that we need to move the decimal over 1 time to turn this into an integer. And when we do that, we also need to move this over 1 time as well. And our decimal will go right up there. So 15 can't go into 10, but it can go into 105. Let's find out how many times. 15 plus 15 equals 30. 30 plus 15 is equal to 45. 45 plus 15 is equal to 60. 60 plus 15 is equal to 75. 75 plus 15 is equal to 90. 90 plus 15 is equal to 105. So that was 1, 2, 3, 4, 5, 6, 7 15s. So we multiplied 15 times 7, and that would give us 105. So now we know that the 7 would go right here, and that would be 7 times 15 would give us 105. We would zero out, and so we know that our answer will be 7. So x will equal to 7 in this instance, which does match what the question is asking. So let's check to make sure that this 7, if we input this for the x value right back into the question, will it work? Let's check now. So we have 1.5. We're going to multiply that times 7, and we're going to add 4 to that, and hopefully we get 14.5. Now, let's do this. So we need to do 1.5 times 7. We know from our previous instruction that multiplying decimals is fairly simple. We just need to move this decimal out to turn it into an integer number. Then we need to count how many times we moved that. And I usually like to circle it so that I remember. Now we need to take the 7 times 5, which equals to 35. You got it. And then we have 7 times 1, which equals to 7. But then we add 3 to that, and that equals 10. Now that we have that number, we need to move the decimal back this many times, which is 1. And we move the decimal right over here. So our final answer will be 10.5 there. But we still need to add 4 to it and see if that equals up to 14.5. So adding 4 to 10.5 would be bring the 5 down, bring the 4 down, and bring the 1 down. Equal sign down, 14.5. That clearly matches up. Therefore, question 2 is verified as well. Good job. All right. Now it's time for our final question. Our final question's equation is 2x plus 12 is equal to 2. Now, this is the same process that we went through for the last 2 examples. So let's go ahead and let's do this. We have a 12 on the side of the variable that we need to go ahead and get to the other side. So we need to do the inverse operation to addition, which is subtraction. And we need to subtract by the same amount that is on this side to zero it out. So plus 12 minus 12 will give us 0. But whatever we do to this side of the equal sign, we must do to this side as well. So we need to subtract 12 from this side as well. We're going to bring this 2x down. We're going to bring the equal sign down. And we're going to do 2 minus 12. Well, if you pull out your number line and you're at 2 here, and you go backwards 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me extend that a little bit and put lines there as well for y'all. So if you extend it, this would be 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, and negative 10. So jumping back 12 from 2, we have a negative 10. Okay, so now that we're at this point, now we need to go ahead and find out what 1x is. So we need to do the inverse operation of what's happening with the coefficient. The coefficient here is the 2 that is in front of the x, and it is multiplying times the x. So what we need to do is the inverse to that operation, which would be division. And we need to divide by the coefficient. Just like we said in the last 2 examples, if we divide by the coefficient, then it will be coefficient, which is 2, over the same number, which is 2. 2 over 2 will give us, or equal out to, 1. Therefore, we will have 1x, or just x. We bring down the equal sign, and remember, whatever we do to this side of the equal sign, we need to do to this side. If we divided this side by 2, then we also need to divide this side by 2 as well. Negative 10 divided by 2. 2 can't go into 1, but it can go into 10. Let's check how many times. 2, 4, 6, 8, 10. That is 1, 2, 3, 4, 5. 2 can go into 10 5 times. 5 times 2 would give us 10. That would zero us out. So our number that we're looking for is going to be 5. But since we have a negative divided by a positive, those opposites will give us a negative. Therefore, our answer here that we get from this would be a negative 5. Now, negative 5 is not the number that we're looking for. We're looking for 7. But let's put it back into the equation and make sure that it is negative 5 here. So we have 2x plus 12 is equal to 2. We're going to sub in that x for a negative 5. All right, now we're going to do 2 times negative 5, which equals to a negative 10, plus 12 is equal to 2. When we combine these two, 12 minus 10 does equal 2. So we have 2 equals to 2. And so our answer is verified, but the verification that question number 3 x is equal to 7, that is the one that is wrong. x would actually equal to a -5. And that's it. Good job. Thanks for joining Mr. Burton's class. As always, hit that like button if you liked what you saw. And you can also hit that subscribe button because we have more videos coming very soon. Take care. Peace.